Hey, it's Tony Fortunato from the technology firm. Today I'm going to walk you through a little baselining exercise and share a whole bunch of little tips, tricks, and all sorts of goodies. I'll jump right into it. So I got a trace file of a Cisco 8832 phone, and I want to do a boot up baseline. And you may want to consider other types of baselines. In this case, it's a phone, so maybe dialing out, maybe receiving a call, that kind of stuff. But the point is, whenever you do a baseline, you break things into different segments. Even your PC, you want to boot up the login, and then maybe starting Outlook, then maybe sending an email. And if you break them up in little chunks, then it's always easier to compare. If you have a problem in the future, it's easier to analyze, it's easier to store, it's easier to digest, and all that good stuff. So this is a phone booting up, and I use this, a Profi Shark, and it's from Profi Tap. I'll put the links in the write-up. I don't sell any of this stuff. Please don't ask me for pricing. And I use this to capture the packets in line. It passes PoE, and it's connected to my machine via USB 3.0. So a lot of good things about that. I'm going to leave it at that. So the tool I used to edit the trace file, or sanitize, or scrub, everybody's got a different word for it, doesn't matter. And I use TraceWrangler, and TraceWrangler is written by Jasper, and I'm going to try his last name, see if I butcher it too much. Jasper, I apologize ahead of time. Bongertz, I believe that's how you say it. I probably did it wrong. I apologize, but I gave it a shot. All right, so Jasper wrote this cool utility called TraceWrangler. It runs on Windows. And basically put a trace file into it, and you can change things like port numbers, IP addresses, payload. I did that in this trace file as well. I changed payload data. So the reason why I did that is this is a real trace file from a customer site. I don't want to reveal any customer information, be it IPs or text, that kind of jazz. So I used TraceWrangler to edit this trace file, and by doing that, now I can use this publicly and show people stuff without compromising any information from my client. All right, here's the trace file. Let's get into it. So here's the trace file of the phone booting up. And I'm going to, again, just share a couple little observations, tips, tricks along the way. So the first thing is the phone obviously sends out CDP packets, and we're going to ignore that for a second. And then the phone goes into its little DHCP dance, its process, if you will. Now, DHCP is basically a four-step process, just a very quick review for people. You have your discover, your offer, your request, your acknowledgement. That's pretty well the basics right there. There's some other stuff later that I'm not going to get into, but you can see very simply what the four steps are. In my case, I always tell people when I present, it's easy for me to remember the four-step process because the initials of the four-step process spells my mother's name, Dora, and that's what it is, Dora. Discover, offer, request, acknowledge. Discover, offer, request, acknowledge. Little tip, if you ever want to troubleshoot DHCP, some things you should know: do not filter or do a display filter on MAC or IP addresses. You may miss half the traffic. I'm not going to get into that. I've written other articles about that already. And the other thing is, if you do want to track a conversation, a DHCP conversation, I would suggest either use DHCP as a protocol filter, or this. You use this little transaction ID at the end of this packet, and that would be the same for this conversation. And there it is, transaction ID 56565656. So in this case, it's from the client. It's pretty obvious. But if you were on a backbone, if at the server end, you might want to peel off one DHCP conversation, and you can use that to do that. So client sends a discover packet. It's looking for DHCP server, and the DHCP server pings an IP address, and that's actually, I'm going to say, not quite common, but it's common for a DHCP server to say, I want to assign this address, but you know what, let me ping it, see if it's in use, and hopefully nobody responds. And if somebody does, well, then I'll mark it used, and I'll move on, and I'll give them another one. And that's what this little echo ping, this ping packet, is doing. And these little things are really important, because if you do anything on your network to block ICMP, firewalls, software, hardware, that kind of jazz, then these may not get there, and it may actually affect the way DHCP works in your environment. So it's important to understand all little nuances of how things work. There's the offer from the DHCP server, and I'm just going to open this up just for 1 second. I want to show you inside the packet. Move down a little bit. Here's all the stuff that's being provided, typical stuff that you would think of. You've got, of course, the lease time, you've got the subnet mask, you've got the router, DNS, TFTP, because it's a phone, it needs TFTP information. And then, this is the cool part, the phone requests information, right? And you can see down here what the phone is requesting. And it looks like a fairly small list, but inside of this parameter request list is a whole bunch of stuff. And you can see one of the things that it's looking for is the network time protocol server right there. So the phone is asking for an NTP server basically, right? It originally was not being provided by the DHCP server, but the phone's asking for it. So it's not going to get one. Basically, that's the end of that. But the interesting thing was, as I look through this trace, if I just type NTP for a display filter, you'll see that the phone is trying to talk to a time server somewhere. It's using NTP version 3. You see them go out, but nothing comes back. So the point of this exercise is you start to wonder, well, this 1985.123, where did that come from? So there's a few ways to go about this. Now, the easiest way I find, I'm just going to clear that out for a second. If I just did an NTP filter, I got those NTP packets. That's not necessarily what I want to do. So I'm going to back up again, clear that out, and I want to search. So Control F or Edit Find. I'm going to search for NTP. This is the important part, packet bytes. So just a quick review. This is called the packet list, packet details, packet bytes. I want to search in here somewhere. I want to search for the word NTP. I could also search for that IP address, that NTP address that was in there. But in some environments, the NTP might be the same as the DHCP, might be the same as the DNS. You may get a little confusing, right? So I'm going to search for the keyword NTP to see if anything pops up. So find. And it highlighted packet 60. And you can see here it highlighted the text in the actual packet as well. So I'm going to right click on 60 and I'm going to follow the TCP stream. Now this is helpful in this example for two reasons. One, it's TCP based, and the second thing is it's clear text. So I'm able to take a look inside of this packet. So TCP stream is going to rip off all the payload and it's going to give it to me in a nice little cute screen like this. So now I can see everything involved with this file. Now if I just move this aside for 1 second, back to the trace file. Now that I've done that, follow the stream, you'll notice the display filter stream equals 3. So in Wireshark, all the TCP quote-unquote streams are given a value, and that's a quick way to filter on 2 IPs and 2 port numbers. That's what that is. People also call that a conversational filter, a TCP conversational filter, same kind of thing. But here's the point. Earlier, you'll see references to TFTP. Now, TFTP, for the people who don't know this, runs over UDP. All right, I know there's a lot of acronyms. I apologize. It's just the way it is. But when this phone goes and gets all of its files, it's not using UDP or TFTP. It's using HTTP over TCP. Take that acronym, guys. So you can see it, get and the file, blah, 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 blah. And it's using HTTP 1.1. And then the data comes down the pipe. So it's really important for you to understand how your devices work. Traditionally, network devices, such as phones even included, will use TFTP to get things like config files, firmware, that kind of stuff. In this example, this phone is using HTTP over TCP. And again, look at the port numbers. The port numbers, not port 80. So these are things you need to know if you need to put a phone somewhere and there's a firewall or a router rule that you need to create. These are the kind of things that you should note. All right, so back to this. Follow the stream. Okay, so follow the stream. If I come down to the find dialog box, NTP, enter, it found the NTP section. We scroll down just a little bit and you'll see that it says name, and there it is, right? So what that means is, as part of its quote-unquote list of files that it downloads, this being one of them, this XML formatted file, it has an entry within it that has an NTP server that the phone is using, but that NTP server does not exist. So we need to go back to the voice administrator. He needs to go back to his configuration panel. Every vendor has a different name for it. I'm not going to get into that. And he needs to go back and configure this XML file with the proper NTP server. And that's it. So, a little review. What do? We powered on a box, in this case a phone. We got the boot up, review DHCP, and then we noticed NTP was going out nowhere. Try to find out why it was talking at the device, how did it get that IP, and now we have an idea of how we can go back and tweak it. Now again, the phone worked fine. This is a tuning exercise. It's also a learning exercise so you can properly baseline, profile, and document your application/phone. Well, there you go, folks. Have a good day. Bye for now.